The first question for projectile motion is: a ball is thrown horizontally from the roof of a building, 45 meters tall and lands 24 meters from the base. What was the ball's initial speed? We have known that y equals 45 meters and the range is about 24 meters, and the vyo is 0 meters per second, and the acceleration is minus 9.8 meter per square second. And according to the equation, y equals yo plus vyot minus half of gt squared. Yo equals 0 and vyo equals 0 too. So we have known that minus 1 over 2 gt squared equals y. So minus 1 over 2 equals 45 meters. T squared equals 19 over 9.8. So we can easily solve that. So the time is about 3.03 seconds. And it is also the time for the horizontal direction. And we know the range is about 24 meters. So according to the formula, V equals S over T. We can know that is 24 meters over 3.03 seconds, and it's about 7.9 meter per second. And that's the answer for this question. And the second question for the projectile motion is that a football is kicked at the ground level with a speed of 18 meters at the angle of 35 degrees at the horizontal. How much later does it hit the ground? We have two solutions here. One is that we can use the formula directly. T total is equals 2vi multiply sine theta over g. And we can just put the numbers here, and we can know the time is about 0.21. And as for the second solution, we know the speed here, and for the maximum height, we know the vertical speed is almost 0 meters per second. And we know the VO here and the degrees here, so we can know the VY0 is equals sine theta multiply VO is about, so the Vy0 is about 1.032 meters per second. And we can just take this number to the formula, and we can know the 1.0 meters per second minus 9.8 t equals 0. As for y the symbol is negative because it is deceleration. So t is about 0.105 seconds. But it's just half of the time, so we double the time. 2 multiply t is equals 0.21 second. And you can see the two time is almost the same. No, it's exactly the same, means those two solutions both correct. So let's move on to the relative velocity. An airplane is heading to the due south of a speed of 600 kilometers per hour. If a wind begins to blow from the southwest at a speed of 100 kilometers per hour, we want to know the magnitude of the velocity. So we can actually put some A, B, C, D here in order to make this more clear. And we know CD equals 100 kilometers per hour, and we can easily know BC equals BD. And then we know AB equals AC minus AB, and we can actually calculate this number. And then we can know AD, and that's the magnitude of the velocity. And let's move on to the second question. A swimmer is capable of swimming 0.45 meters per second in the still water. If he aims her body directly across a 75-meter wide river whose current is about 0.4 meters per second, how far downstream from a point opposite her starting point will she land? And we know this length over this length is actually a tangent of this triangle, and we know this length is actually about 75, and so the proportion is the same. So the displacement over 75 equals 0.4 over 0.45. So we can know the direction is about no the displacement is about 6-7 meters.